Dear students, in this session we are going to see about what is electric current. The rate of flow of charge is called as a electric current. So rate means time. So the flow of charge with respect to time is called as a electric current. Let us see what is charge. So we are all familiar about the charge. The charges are two types, positive and negative charges. So we are know that the properties of the charges, like charges repel and unlike charges attracts. So in this session the negative charge represents the electron. Generally the negative charge is called as a electrons. For the definition of current, we should know about the important property of the charge, which is called as quantization of charge. So what is quantization? The quantization says that the charges never be a decimal number. So it is always in a whole fraction. That is Q is equal to NE. The N represents the number of charges. E represents the value. That means the magnitude of the one charge. Yes, of course the value of the one charge is 1.6 into 10 power minus 19 coulomb. In this equation, the N represents 1, 2, 3, 4. That means the charges may be a 1 charge or 2 charge or 5 charge. It never be a 7.5 charge or 6.2 charge or 4/3 charges. That is, the charges always discrete in nature. Discrete in nature. That is step by step. I will explain the quantization of the charge in clear way. So let us assume that a small surface which has a large number of charges. Okay, it may be a negative or positive charge. We consider the number of charge in this space is N. So the Q represents the total number of charges in this space. N represents the number of charges. E represents the value of the each charge. Now I take that the total number of the charge in this space is 1 coulomb. That means Q is equal to 1 coulomb. So what is the number of charges present in 1 coulomb of? That is 1 divided by, that is Q divided by E. As in our case, the Q is 1 coulomb and E is 1.6 into 10 power minus 19 coulomb. That is, it represents a number. That means a coulomb get cancelled. Finally, by solving this values, we get the answer 6.25 into 10 power 18 electrons. So evidently we found that the number of electrons in 1 coulomb of charge is 6.25 into 10 power 18 electrons. 10 power 3 is 1000, so 10 power 5 is a lakhs, so 10 power 18, imagine that how many number of electrons are present in for a 1 coulomb of charges. As earlier I said that the rate of flow of charge is called as electric current. So the charges are positive charge and negative charge. So we are seeing that the quantization of the charge. So in order to understand the flow of charge very clearly, we should know about the atomic structure. So in the center we have a proton, which is a positive charge, and a neutron is a neutral charge. The nucleus, this is called as a nucleus. This is a first orbit, second orbit, third orbit. The number of electrons in each orbit can be easily found out by using a formula 2n squared. Substitute n is equal to 1, we get 2 into 1 squared, 2 electrons in the first orbit. Substitute n is equal to 2, 2 squared is a 4, 4 into 2, 8, so we get 8 electrons. So likewise we have a number of electrons in each orbit. So in our structure, I consider this third orbit is the outermost orbit. This third orbit is called as outermost orbit is called as valence orbit. The electron present in the valence orbit is called valence electron. So clearly understand that the outermost orbit is called as a valence orbit and the outermost electron is called as a valence electron. The electron present in the outermost orbit can be ejected out by absorbing the external energy. For metals, the room temperature is sufficient to eject out the electrons from the outermost orbit, that is called as a valence orbit. This electron is called free electron. Now we are come to our definition. Current. So this free electron is responsible for the current. So not these electrons. Even these electrons are revolving around the nucleus of inside the atom. So this electron movement never constitute current. Only the movement of the free electrons inside the metal surface only constitute current. The electron which is other than the valence orbit is called as a bound electrons. These bound electrons never contribute to the flow of charges or electric current. Yes. Let us consider the example metal. So we are all know that metal is a good conductor of electricity. So this is a real picture of the metal. What is happening inside this? So this is a metal. The electrons, these free electrons are come out from the atom. So these are all the atoms. As we yearly say that the electron present in the outermost orbit will come out from the atom is called as a free electrons, and the atom will become a positive ion because the number of electrons and the number of proton is always equal in the atom to maintain the stability. When one electron is come out, the number of proton in this atom becomes more. So this atom will become a positive ion. Hence here the atoms are represented as positive ions. So what about these electrons? These electrons which is inside the atom, which is revolve around the nucleus. But when it is come out from the atom, it is not controlled by any electrostatic attraction of the nucleus. So it is randomly moving here and there. So that is in metals, the free electrons are moved random. There is a random motion of free electrons in the metal. Then what makes a current? So only this metal conductor is connected to the battery. Connected to the battery. Then only the electrons flow. That means the flow of charges take place. That is called as a current. So the randomly moving electrons are attracted by this positive terminal. Okay, this randomly moving electrons are attracted by this positive terminal. So these electrons are drifted and move towards one particular direction, towards a positive terminal of the battery. So this drifting velocity is called as a drift velocity or drift speed of the free electrons. For copper, this drift velocity is 1 millimeter per second. Yes. Now only we are coming to our definition. The flow of electrons, the rate of flow of electrons is called as a current. All the electrons, free electrons are moving towards one particular direction. This is a flow of electron direction. So what about the current? From the lower class itself, we have studied that the electrons always flows from positive terminal of the battery to negative terminal of the battery. In an external circuit, the current direction is always taken as a positive to negative terminal, but the flow of electron is towards the positive terminal of the battery. There is one common question arises always by the students, why the current direction is always taken from positive negative? Because the electron's movement is always from negative terminal of the battery to positive terminal. Since we can take it as a current direction as a electron direction. But even before the discovery of the electron itself, the current flow are understood by the scientist. It is only by the positive charges. So positive charges only responsible for the electric current. It is taken by the scientist before the invention of electron by J.J. Thomson. After the invention of electrons, the scientists came to the conclusion the positive charge is not responsible for the current flow, only the electron, that is a negative charge only responsible. So in order to taken as a previous invention as a honoring him, they are conventionally taken as. That's why they are always say that the conventional direction of current is always positive to negative. This is a reason. This is the reason why the electron direction always taken from positive to negative terminal. We are not moving far away. That is very simply I will saying that the rate of flow of charge is called as a current. The charge means positive charge and negative charge. Then quantization of the charge is a very important property of the charge. The charges never be in the decimal numbers. That is means a half charge or 1/4 charge or 3/5 charge. It is only one charge, two charge, three charge. That means n is always even. It may be a zero charges, no charges, one charges, two charges, three charges, etc. So we calculate very simply what is the value of 1 coulomb. That is 1 coulomb of charge having 6.25 into 10 power 18 electrons. In order to explain the importance of the free electrons, we are studying about the structure of the atom. Then we come to the conclusion only the free electrons are responsible for the current flow, not all the electrons present in the atom. So we will see that without the battery, the free electron motion is a random motion inside the metal conductor. By connecting the battery, we are seeing that evidently we seeing that the free electrons are moving towards one particular direction, towards positive terminal of the battery. That velocity is called as a drift velocity. For copper, the drift velocity is 1 meter per second. Yes, directly I will come to say that what is current, sir? The current is defined as the rate of flow of charge per unit time. Okay, so I will say that what is the SI unit of charge? The SI unit of charge is coulomb. As early we are saying that 1 coulomb means that is a unit of charge. That is the unit of charge is coulomb. Always write the unit in small letter when it is a scientist name, but the symbol can be represented in capital letter. For example, Newton, you should write only in small letter, but the symbol of the Newton is capital N. Similarly, the SI unit of current is ampere. So it is a symbol is capital A. So the current is represented as a ampere, and charge is 1 coulomb of charge by 1 second. Yes, what is 1 ampere? 1 ampere is defined as 1 coulomb of charge flow in 1 second. So the device used to measure the current is called as ammeter. The ammeter is a device used to ammeter is a device used to measure the current. It is always connected in series. Why it is always connected in series in a circuit? Because the ammeter is a device which has a very low resistance. In order to understand what is the resistance, why it has a very low resistance, why it is always connected in series, that part and all we are going to see after the Ohm's law session. Yes, the very low current, the ampere measurements may be done by the milliampere or microampere. Milli means 10 power minus 3 ampere, micro means 10 power minus 6 ampere. So now I will conclude my session. So what is the electric current? The electric current is a rate of flow of charge, that is the charge by time. The SI unit of charge is coulomb and time is second.